Hello, everyone. In this video, we will give a guide and tips for chapter 18 of my Java book. Chapter 18 introduces recursion. Recursion is a technique. You write a program, write a method, and that method invokes itself. So this is called recursion. And this is a very useful technique for writing code for recursive problems, for the problem and that are inherently recursive. Well, we're going to look at the examples here. And this is the introduction. You're going to see some of the inherently recursive problems, including this H-shape problem. So you're going to draw this kind of shapes recursively. So it's using recursion, you can draw it. Without using it, it's going to be quite difficult. You still can do it, but it's very difficult. All right, so here we're going to introduce recursion using a very simple example and just illustrate the idea and what is recursion and how we solve it, and using this computing and factorial. So we have the animation to see how recursive method is executed. And here's another animation to see the call stack, the change of call stack. When you invoke a method, you create a call stack to store the information for the method. So here is how this works for this factorial method. And the next is another classic example to illustrate recursion and using the Fibonacci number. So finding the Fibonacci number and using recursion. Now, so this section we discuss more on recursion in general, how you write a recursive program. So the next section is recursive help methods. Sometimes you have a problem, you have a method, you want to invoke it, but it's not clear you can do it directly. So you can have a helper method. Helper method is a overloaded method, the same name, and you just give the different parameters that will enable you to call it recursively. So this is called a helper method. So now we're going to look at some problems that are inherently recursive. So we're going to solve them using recursion. So prior to this section, we introduced recursion, and using the problems, there's simple problems. They're not necessarily good candidates for solving using recursion. But now, and we're going to look at the very inherent recursive problems. There are solutions. Their solutions should be done using recursion. So using recursion, we can solve this type of problems effectively. All right, so here's the directory size problem. We're going to find, given a directory, we find all its subdirectories, all the files under the directory, and the total size is the directory size. So we write a recursive program for this. So the next is another classic problem for recursion. It's the Tau or Hanoi problem. We find out and how to move the disks from Tau A to Tau B with the assistance of Tau C. When you move the disks, you move one at a time. At any time, the smaller size of disk is placed on top of the large disk. So this is the Tau of Hanoi problem. And then another classic problem is this is the fractal problem. So the fractal problem, we draw the recursive shapes. So using recursion, we can draw these shapes easily. So this is the Sierpinski triangle. So we look at the 4 and we look at the 5. So this is, it's quite difficult if you don't use recursion to draw it. So using recursion, you can write simple, natural, and efficient code. Now we're going to look at this recursion versus iteration. So we can write a code using loop in most cases, and loop works actually better, and then recursion. But for some problems, the problems that are inherently recursive, we use recursion, and the solution is straightforward. It's more elegant. It's a natural and easy to derive. So this is the difference between recursion and iteration. And one more thing is, if a simple problem, you can solve it using iteration, and using iteration is always better because a recursion has more overhead and memory space and also time. Well, the last thing we'll touch is on tail recursion, is a special kind of recursion. So in the method, and once you return you call a method recursively, but once it's a return, it's finished. So there's no pending operations after you return. So this kind of recursion is called tail recursion. Tail recursion is efficient to implement it because you don't have to store all this information on top of the stack. And because once it's returned, it's finished. So there's no need to store all this, keep all the history. So this is, and we discussed this, we give animation and how tail recursion works. Well, just one note is that tail recursion is actually not supported in Java at this moment. So, but we want to illustrate it here, and you can see it in general and what tail recursion is and how it works. Well, that is all for this chapter on recursion. Thank you for watching. Goodbye.